Hi, I'm Steven. You're watching Steven Loves Science. So, in the last video we made on molar mass of gaseous substance, I left out a problem that I did not want to leave out. You know what? I ended up thinking that I'm glad I left it out in the last video because this is a long problem and there's a lot of steps and it's very difficult to explain. So, let's start with the problem. Now, I'm going to move over here so that I may place the text of the problem over here. So, chemical analysis of a gaseous substance showed that it contained 33% silicon and 67% fluorine by mass. At 35 degrees centigrade, 0.21 liters of the compound exerted a pressure of 1.70 atm. If the mass of 0.21 liters of the compound was 2.38 grams, calculate the molecular formula of the compound. So, hopefully that's up there. Now, before we go ahead and start tackling this problem, I've written a list of steps because once we get into it, I do not want to get lost and confused in the sea of steps. Okay, so first, we're going to want to find the number of moles of silicon and fluorine in the substance. Then, our first step is to find the empirical formula, because before we can find the molecular formula, we have to know the empirical formula. So the first step in finding the empirical formula is to find the number of moles of each substance. So we want to find the number of moles of silicon and the number of moles of fluorine. Then we're going to set those numbers of moles equal to the subscripts for each one. Then we're going to get the empirical formula for the compound, and I'll show you how to do that when we get to that. And we're going to record the molar mass of the compound because we're going to need it later. Then we're going to find the molecular weight of the molecular compound. So for the molecular formula, so we're going to need the weight of the empirical formula and of the molecular formula to do this problem. And then lastly, to finish the problem, we're going to divide the molecular weight by the empirical weight to find the ratio between them and finally get our molecular formula. So, let's start by finding the empirical formula. So when finding the empirical formula, we're going to want to assume that we have 100 grams of this substance. So let's assume that we have 100 grams of our substance. So if we have 33% of our substance is silicon and 67% is fluorine. That being said, if we have 100 grams of this compound, 33 grams of it should be composed of silicon, and 67 grams of it should be composed of fluorine. Now our first step is to find the number of moles. So we're going to find the number of moles in 33 grams of silicon, and we're going to find the number of moles in 67 grams of fluorine. So, number of moles of silicon equals, and our conversion factor for finding the number of moles of silicon is 1 mole for every 28.09 grams, and we find that the number of moles of silicon in this problem is 1.17. And doing the same thing for fluorine, number of moles of fluorine, grams. Our conversion factor for fluorine, however, is 1 mole for 19.00 grams. Now, in doing this, we find that the number of moles of fluorine is equal to 3.53. So let's go ahead and erase this and get this out of the way. We know that our number of moles of silicon is 1.17, and our number of moles of fluorine is 3.53. So our second step says to set N equal to the subscripts. So that means for silicon, it would be silicon with a subscript of 1.117, and fluorine with a subscript of 3.53. So then we're going to divide by the smaller subscript, because we're going to want to get an empirical formula with one of them equal to 1. So in order to get the smaller subscript out of the way, we're going to divide, and we're going to divide, so that our subscript, when we divide, it has to be an integer. So you're going to round. So silicon is 1, and when we divide this, we get fluorine to 3. So this is now our empirical formula. So we're going to record the molecular weight of it. Silicon has a weight of 28.9, and fluorine has a weight of 19, but there were 3 of them, so that means that in total it's going to have a molecular mass of 85. So the molecular mass equals 85 grams per mole. Okay. So now we're going to move to the next step. So now we're going to find the weight of the molecular formula. But we don't know the molecular formula yet, but that doesn't mean we still cannot go ahead to find the weight of it, because it gives us enough information in the problem to find the weight. So, in order to do that, we need to find the number of moles in 2.38 grams of our unknown substance. So, to do that, number of moles equals PV over RT, and plugging in our numbers, 1.70 atm times 0.210 liters over our proportionality constant, which is going to be this, 0.0821 times the temperature in Kelvin, which is 308 Kelvin. In doing that, we find the number of moles in 2.38 grams of our unknown substance with the molecular formula that we do not know is 0.0141. Now, with this number, we can go ahead and find the molar mass of the molecular formula. Okie dokie. So in order to find the molar mass of our molecular formula, we know molar mass is going to equal our number of grams of substance over the number of moles of substance, and that's going to equal 169 grams per mole. So that means the unknown molecular formula has a weight of 169 grams per mole. Now we can go ahead and find that very simply by taking the weight of the empirical formula and dividing it by the weight of the molecular formula. So in doing so, 169 over 85, we're going to get an integer value of 2. Because remember, when we do this, we only take integers because you can't have decimal. So the ratio is 1 to 2 from the empirical formula to the molecular formula. So that means if we want to get this, if we want to get our empirical formula to the weight of the molecular compound, we simply take it and multiply it by 2. So that is the equivalent to Si2F6. And this is the molecular formula for the compound. So that was a little confusing. I'm not going to make the video again because I'll make a video on gravimetric analysis, and hopefully that'll be better. Once again, this is only my 4th video, so I hope to improve my ability to teach and my teaching skills improve. I'm not a teacher, I'm just trying to be, so I hope that I improve. Thanks for watching, have a good day.